Okay, let's go ahead and find the volume of this tetrahedron in the first octant bounded by the coordinates planes and the plane passing through these points. So we have the back, which is bounded by the XZ plane, and this back right here bounded by the YZ plane, and the bottom is bounded by the XY plane. And you can look at this plane right here that will cut through those 3 points. Let's go ahead and find the equation of this plane. So we're going to need to do the cross product to figure out the equation of the plane. So hopefully you remember how to do the cross product. If you don't, I'll leave a link in the description box for you to check it out. So let's create a vector from this point right here, from this to that. So we're going to create a vector from here to here and a vector from here to here. So let's give them a name. Let's call this point A, B, C. So the vector created from A to B, let's do that one first. So we take the final point, subtract the initial point. So that's going to be 0 minus 1, that's -1. 0 minus 0, that's 0. 3 minus 0, that's 3. And then we're going to create a vector from A to C. So that's going to be, again, final point minus the initial point. 0 minus 1, -1. 2 minus 0, that's 2. And then 0 minus 0, that's 0. Now we find the normal of this plane by performing the cross product between these vectors, AB cross AC. Now, when you do that, you have to be very careful. So we're going to go ahead and see how that looks like. So I'm going to try to just give you the result without performing the cross product, but feel free to review that on your own. So the first component of this vector, you're going to get your normal vector to be -6, -3, and -2. Now, if you're going to pull out the factor of -1, you can also do that. So I will just go ahead and write out the equation of the plane using this point A. So our equation of the plane, it's going to be its normal. So that's -6 times x minus xo minus 3 times y minus yo, that's 0. And then minus 2 times z minus zo, that's also 0, equals to 0. And then if you clear this up, we're going to get -6x minus 6 minus 3y minus 2z equals to 0. And then let's move everything to one side and multiply by -1. So you're going to get 6x plus 3y plus 2z is equal to 6. So that's the equation of this plane that's creating this shape, tetrahedron, bounded by the planes, the coordinates plane. Now you can check this is the right equation by plugging in the points. For example, when y and z are 0, you get this point right here. And then when x and z are 0, you get that point. And then when y and x are 0, you get z equals 3. So you get the point B. All right, so we got the equation of the plane. Now let's find out the volume. The volume is going to be triple integral. So we're going to set up the volume of this solid, let's call it E, is going to be the triple integral of 1 of dV. So that's how you're going to set up the volume. Now we need to figure out our limit of integration. So you can do it in 3 different ways. In fact, 6 different ways, but I'm going to show you just probably 1 or 2. So let's take a look at this way. So imagine you have a bottom surface and a top surface. So we're going to look at projection of this plane onto the XY plane. So if you project it down, your shadow in the XY plane would look something like this. So here's our XY plane. And we're going to project this into the XY plane. So we're going to pass through this point 1, 0, and also 0, 2. So that's this point right here. So it's going to create this triangular shape. So that's this right here. That's the projection in the XY plane. And the Z is going to go from bottom to top. So you can imagine putting a block right here, and then it has a height. So you have a top surface and a bottom surface. So Z, you will have a Z bottom and Z top. So our Z is going to go from 0 to the top surface, which is this surface right here. So you just solve for Z. So if you solve for z, you can do subtract 6x minus 3y divide by 2. So the top surface is going to be 6 minus 2x minus 6x, I'm sorry. So this will be 6 minus 6x minus 3y divided by 2. So that's the top surface. And then the bottom, the floor, is going to be our region R. So we'll set up a double integral in this region. So you can create another vertical cross section. So now x is going to range from a number to a number. So that's going to go from 0 to 1. So we're integrating here. And then y will range from 0 to that line. So y is going to go from 0 to this line right here. We need to find the equation of that line. The equation of this line, it's going to be, you can find the slope and you'll get negative 2x and y-intercept is plus 2. So that will be the range for y. We're going to have negative 2x plus 2. So these are our bound for a limit of integration for x, y, and z. So our inner integral will go from z values from z bottom to z top. And our outer two integrals are going to be along the y first and then along the x. So we're going to set it up this way. So here we have the triple integral. So z bottom is 0. Z top was this right here. So it's this 6 minus 6x minus 3y. So you can write this as 6 minus 6x minus 3y. Divide that by 2. That's the upper bound for z. And then we're bound for y, it's going to go from 0 to negative 2x plus 2, and x is going to go from 0 to 1. We're integrating the function 1, so d, z, dy, dx. That's one way to set it up. You can set it up differently if you feel like doing different order of integration. So let's continue on. So we're going to go ahead and do the inner integral first. So this one right here, respect to z. So we rewrite the rest. So we have the integral from 0 to 1, then the integral from 0 to the function negative 2x plus 2. When I integrate one respect to z, I got z, and then we're going to evaluate from 0 all the way to that function. I'm going to simplify that. 6 divided by 2, that's 3 minus 3x minus 3 over 2y. And then we still have to integrate respect to y and x. So let's plug in the upper limit of integration. So we got the integral from 0 to 1, then 0 to negative 2x plus 2. We have plugging in the upper bound for z. You get 3 minus 3x minus 3 over 2y. So when you plug in the lower limit for z, you're going to get 0. So we don't really need that. So we can just write dy dx. And now we proceed with integrating this respect to y. So continuing on with now the next variable. So we have the integral from 0 to 1. If I integrate each term respect to y, we're going to get 3y minus 3xy minus 3 over 2 y squared over 2. So we can just write that as 3 over 4 y squared. We're going to evaluate from 0 to negative 2x plus 2, and then we're going to integrate respect to x. Okay, so a little bit of clearing up to do. So we're going to substitute the upper limit and the lower limit now in place of y. So here's what this is going to look like. So we have the integral from 0 to 1. Let's plug in the upper limit first. We have 3 times negative 2x plus 2 minus 3x times y. That's negative 2x plus 2 minus 3/4 y squared. That's negative 2x plus 2 squared. When you plug in 0, you're going to get 0. So dx. All right. So this is what our integrand looks like. Now let's distribute. So this is equal to the integral from 0 to 1. Here we distribute out the 3. Here we distribute out the negative 3x. And then next term we're going to expand and then distribute. So we got negative 6x plus 6. And then positive 6x squared. And then negative 6x. And then here we're going to get negative 3/4 times positive 4x squared minus 8x plus 4. And then we distribute out the negative 3/4. So close it up, dx. Now let's combine some like terms. So it looks like we can combine some terms. So I guess we can combine these for now. So we have the integral from 0 to 1 of negative 12x plus 6 plus 6x squared. And then here we can distribute this out and simplify. So we got 4 and 4 will cancel with the x squared. So that's negative 3x squared. And the negative 8 divided by 4, that's going to be negative 2 times negative 3, that's positive 6x. And we get negative 3 as you distribute to the 4. All right, dx. Now let's combine more like terms before we integrate. So integrating 0 to 1. Here I can combine these. So that's going to give me it's 3x squared. Now these are like terms, so I guess 6 of those negative. So negative 6x. And then here 6 and negative 3, that's positive 3. And now we can integrate respect to x. So as you integrate, your first term will be x cubed minus 6x squared over 2. So that's going to be 3x squared, and then plus 3x, and we're going to evaluate this from 0 to 1. So we get 1 minus 3 plus 3. Plug in 0, you get 0. These will cancel, and this will give you 1. So the volume of this solid bounded by the coordinates plane, and by that plane, it's going to be 1.
Now let's take a look at the same problem again, and we're going to set up the volume in a different order of integration. Let's say our volume of solid E is going to be this triple integral 1 times dv. Now let's say that we want to do dv as dx first and then dA, where dA will be the shadow projected onto the YZ plane. So this will be determined by looking at the shadow in a YZ plane. So that's what we're going to do. So that way you get to practice a little bit of how all of these going to be set up. So there's 6 different ways you can do, but I'm going to show you one more way of setting this up. So imagine you have a line parallel to the x-axis. So imagine something like this, maybe a cross section, and you have a z, an x, you have a front and back. So you have a x function that will go on the back. Let's call this x bottom. And then here you will have the x top. So these are the limit of integration for our x component. So we can set up the bound for our x. X will go from z, x bottom will be 0. So you can see this backside x bottom is going to be 0. Now we need to figure out what's x top. Well, x top is the plane, but we need to solve for that plane in terms of y and z, so we'll solve for x. So if you recall the equation of this plane, we said that it was 6x plus 3y plus 2z equals to 6. So what we're going to do is solve for x. So that will be the x top, or x front, if you want to think of it that way. So you have 6x is equal to 6 minus 3y minus 2z, and divide by 6. So x is equal to 1 minus 1 over 2y minus 1 over 3z. So that's going to be our z top. So you'll have 1 minus 1/2 y minus 1/3 z. All right, so that's done. So when we're setting up the triple integral for our volume, so let's go ahead and write that down. So our volume of this solid, another setup would be the triple integral. So this will be the shadow. Let's call that region R. But now x will go from 0 to that plane. So that'll be 1 minus 1/2 y minus 1/3 z, 1 dx, and dA. Now let's figure out dA. So dA will be the projection of this plane onto the YZ plane. So if you project it, let's see how that will look like. So here's our YZ plane. So this is Y, this is Z. So we know we're going to intersect the Z axis at 0, 3. So when Y is 0, Z is 3. And then on the Y axis, we're going to intersect at 2, 0. So you don't need the X component on this one. X is 0. So this is our region R in the YZ plane. So this is what we're going to integrate now. So this, you can treat it as type 1 or type 2 for a double integral. So I'm going to imagine there is a cross section right here, set it up as a vertical cross section. So we can do dz first and then dy. So let's pick our limit of integration. So our dA, we're going to select that to be dz dy, which means y will now range from here to here. So that will be from 0 to 2. And then z is going to range from bottom to top. So the z bottom is going to be 0, but z top is going to be this line. So we need to find the equation of that line. So the equation of that line is pretty much the equation of the plane, except your x component is 0. So you know this is going to be 3y plus 2z equal to 6. And then you solve for z in terms of y. So z is going to be 6 minus 3y divided by 2. And then you simplify that. That's 3 minus 3 over 2y. So that's the upper bound for z. So you'll have 3 minus 3 over 2y. All right, now we're ready to fill in our triple integral. So our triple integral, another way to set it up would be to set up these bounds. So we know now r, we're doing respect to z first and then y. So the bound on z will go from, like we said, 0 to the line 3 minus 3 over 2y, and bound on y will go from 0 to 2. So our dA, we now replace it with dz dy. So there you have another setup for that same solid in different order.